Hello everyone. In this video, we're going to be solving a very nice problem, a Quartic equation that appeared in a really nice book. And I'll share the name of the book with you. We have this equation with a parameter, which is a, x squared plus 1 multiplied by x minus 1 quantity squared, and that is equal to ax squared. And for all values of a, basically, we're going to be looking for x values. And let's go ahead and approach this problem from two different angles. The first method that I'm going to show you is kind of like a general approach for Quartic equations, which may or may not always be the best approach, but you'll get to decide. So let's start with the first method. Obviously, I'm going to go ahead and distribute everything. So x squared plus 1 distributed over x squared minus 2x plus 1 should give us ax squared. Let's go ahead and distribute this, x to the fourth minus 2x cubed plus x squared, and then plus another x squared minus 2x plus 1, and then let's go ahead and subtract this so that we can put everything on the same side. We have some like terms, these three, and then this is going to be x to the fourth minus 2x cubed. Now if you collect the like terms, you will get 2 minus a as the coefficient of x squared. And then minus 2x plus 1 is equal to 0. Now, we have a way of solving Quartic equations, but what makes this problem really complicated is the fact that we have a parameter a. So for any value of a, we're going to have a different Quartic. So in other words, we're looking at a family of Quartic equations instead of a single Quartic equation, which makes this problem much more interesting. Great. Now, where does this problem come from? It comes from 101 problems in algebra from the training of the USA IMO team. So these problem and many others were used in the training of the United States of America International Math Olympiad team, which is a number of 6 students that compete with other students from about 80 countries. So 500 students roughly worldwide will compete, and they will try to solve 9 problems. They will try to solve 6 problems in 9 hours, and that's over 2 days. Just crazy, right? Insanity. Now, let's go ahead and look at this equation one more time. What are we going to do with this? So I'm going to show you a method that you can use to simplify the problem. Okay? So here's what we're going to do. We're going to go ahead and isolate these two terms on the left-hand side, and then we're going to try to turn this into a perfect square, okay? So I'm going to write it as x to the fourth minus 2x cubed. Everything else will go on the other side, so it's going to look like this. We're going to negate x squared, we're going to negate 2x, and we're going to negate 1. Great. Now, our goal is to make the left-hand side a perfect square, and then make the right-hand side a perfect square, so we'll have 2 perfect squares. If m squared equals n squared, then from here you can conclude m equals n or m equals negative n, right? Great. That's what we're going to achieve, hopefully, or at least try to get there. So in this case, if I add x squared to both sides, which makes sense because we already have x squared on the right-hand side, I could also split one of them. It's the same idea, but the coefficient of x squared on the right-hand side is now going to be a minus 1. Everything else is unchanged. So we're going to get an equation like this. Let's go ahead and erase this. Hopefully you know the idea. Now, why did I add x squared? You might be asking, right? Because the left-hand side is now x squared minus x quantity squared. Great. How about the right-hand side? Can it also be a perfect square? That would be awesome, right? Don't you think? Well, it would be, but we have a problem. Houston, the only problem we have is this is a minus sign. Now, here's the deal. If a minus 1 is negative, then we're going to be okay. Why? Because in a quadratic equation like ax squared plus bx plus c, if you remember, delta or the discriminant tells you how many real solutions you have, b squared minus 4ac. If ac is negative, this is always going to be positive. If ac is negative, which means a and c, one of them is negative, the other one is positive, so on and so forth. That's the scenario we have here, right? So it's not going to be a perfect square because delta will be positive, which means you have 2 distinct real solutions, okay? So what should we do then? The only possibility then, as I told you earlier, is that this a minus 1 to be negative. In that case, we can be okay. But what does that mean for a minus 1 to be negative? It means a is less than 1. Okay, is there a value of a that is less than 1? That will work. And if that works, then hopefully we can proceed with the solution. Let's check it out. I'm going to be copying that over here so that you don't have to go back and forth like crazy. This is a minus 1 x squared. That's how much I remember that. Plus 2x minus 1 is our equation. Okay, now we want, in order for the right-hand side to be a perfect square, we want the delta to be what? 0, right? What is delta? B squared minus 4 times a minus 1 times negative 1. Of course, this is going to give you 4 plus 4a, because that is going to make it positive, minus 4 equals 0. From here, 4a equals 0, which means a is equal to 0. So, if a is equal to 0, we get a perfect square. How nice is that, right? Let's go ahead and do it. So, if a is equal to 0, we get negative x squared plus 2x minus 1, and then we get negative x minus 1 squared. Uh-oh, Houston, we have a problem. And what's that problem? The left-hand side is a perfect square. But the right-hand side is the opposite of a perfect square. How can a perfect square be equal to the opposite of a perfect square? Well, if you put everything on the same side, you're going to get something like this. And you can easily conclude from here that if the sum of two squares is 0, and if x is real, then both of these have to be 0. In which case, you get x equals 1 is the only solution. But is that valid? And why doesn't it depend on the value of a? Well, we just said that a is equal to 0. So this is true if a is equal to 0. But the question is, the million-dollar question, is x equals 1 the only solution to this equation? And by the way, x equals 1 works only if a is equal to 0. And we said that we're going to find a solution for all possible values of a. How about if a does not equal 0, right? That's a good question. Absolutely. Now, so we kind of have to go back here and also consider another fact. This can be true if x is complex. Why? Because you can square root both sides with an I in it, and you can proceed with the solution. Let me show you how that looks like, or what that looks like. So you can kind of square root this, and when you square root this, you just have to have a plus minus I here. Because when you square I, you get I squared is equal to negative 1. Did you know that? If not, go ahead and check out A plus BI, a channel dedicated to the world of complex numbers. All right? So from here, obviously, we're going to get some complex solutions, so on and so forth. But that's not our goal either. You can do it, not a problem, but I want to get a more general solution. So let's go ahead and proceed a little differently here. So I'm going to pick it up from here. Let's go ahead and erase this area. And obviously, I'm lazy, so I don't want to copy this equation one more time. Hopefully, you don't mind. Okay. Now, let's go ahead and see what we can do with this. Well, notice that if the right-hand side is a perfect square, it's the opposite of a perfect square. So we don't want that. Let's do this. Can we add something to both sides while keeping the left-hand side a perfect square and making the right-hand side a good perfect square? And the answer is yes, okay? I can't remember what method is this called, Descartes or I don't know. Some guy found it. Anyways, we're going to be adding 2k times x squared minus x plus k squared. Why? Because this makes it another perfect square. And of course, you have to add it on both sides. So let's go ahead and add it here as well. And when you add that, you're adding these basically, 2k x squared minus x plus k squared. What happens to the left-hand side? Well, the left-hand side becomes x squared minus x plus k quantity squared. And the right-hand side, of course, we need to work on this a little bit because we have some quadratic terms. Let's see how we can fix that. Okay, gonna erase this area. Uh-oh. All right, now, if you put together these two things. You have a minus 1, but then you also have 2k. So a plus 2k minus 1, that'll be the coefficient of x squared. And then, what x terms do you have? You have 2x and then minus 2kx. So it's like 2 minus 2k. That's going to be the coefficient of x. And then we have some constants, which is given by k squared minus 1. And that concludes our equation. Beautiful, right? Now, here's your goal, because I'm going to leave it at this point. Sorry about that. This left as an exercise for you guys. You want this to be a perfect square, so delta needs to be 0. Can you find k values from here so that you can solve this equation? But guess what? Your answer is going to be in terms of a. That's why we do have something called the second method. And guess what? These problems were prepared on purpose, or you could say contrived, to prepare students for math competitions, including IMO. So there's usually a nicer way to do it, right? So let's go ahead and take a second look. X squared plus 1 multiplied by x squared minus 2x plus 1, remember, minus ax squared equals 0. Beautiful. Now, we know that x equals 0 does not satisfy the equation. How do we know that? Replace x with 0, you're going to see that it doesn't work. So this is what we're going to do next. This is the best part, I think, in my opinion. We're going to divide everything by x squared. This one by x squared and this one by x squared. And of course, 0 by x squared, but that's still going to be 0. Now, we're going to do it in an interesting way, not just divide the product, but divide this one by x and divide this one by x. So we're going to kind of split it up. Make sense? If you divide this by x, you're going to get x plus 1 over x. If you divide this by x, you're going to get x minus 2 plus 1 over x minus x squared cancels out, a equals 0. Awesome. Now we're going to make it more awesome. Now this is x plus 1 over x multiplied by x plus 1 over x minus 2 minus a equals 0. Now, notice that x plus 1 over x shows up. So we're going to call this y. And now you have y times y minus 2 minus a equals 0. Or y squared minus 2y equals a. And guess what? You can add 1 to both sides to complete the square. That's going to be a really nice perfect square. And you can definitely solve this equation for y. Let's do it. Y minus 1 quantity squared is equal to a plus 1. As you know, when we take the square root, you're going to have the absolute value, the plus minus sign. So y minus 1 is going to be plus minus the square root of a plus 1. Beautiful, right? This is not the end of it. Let's go ahead and solve for x from here. But let's go ahead and isolate y first. So I'm going to add 1 to both sides, and we get y in terms of a. Beautiful. Now, what is y? Y is x plus 1 over x. So now we're going to set x plus 1 over x equal to this. Well, let me tell you something. If you just, for a moment, replace this with y and solve x and then plug it in, I think your life is going to be a tiny bit easier, in my opinion. Multiply everything by x. And then put everything on the same side. And then from here, solve the quadratic for x, treating y as a constant. Negative b plus minus the square root of b squared minus 4ac all over 2a. Now you can go back and replace y with what it is. It's that beautiful radical. And of course, you kind of have to do this twice. So kind of like maybe use the plus 1 first and then do the second one next, like this. And then this is y plus minus, and then inside you're going to have the same thing again, but you have to square it this time, right? All of that is multiplied or divided by 2. And then at the end, you're going to be getting all the solutions, okay? But you have to be careful about this, because depending on the values of a, you're going to get different values. And this is a quartic, so it has 4 values. So I'm going to go ahead and give you, if a is greater than or equal to 0, then you're going to have the following solutions. 1 plus the square root of 1 plus a, plus minus the square root of a plus 2 times the square root of 1 plus a minus 2, and all of that is divided by 2. Plus minus is going to create 2 solutions, and then in addition, there are also other solutions. Guess what? They are all real for certain values of a, which we need to check, or which you need to check. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out aplusbi, and bye-bye.